So in this video, we're going to look at neutrinos and look at them in a bit more detail and kind of resolve the thing I was talking about in our last video about how this wasn't actually telling the whole story about what was going on. So neutrinos barely interact with matter. We were talking about how the kind of forces that leptons experience, but we're going to see that neutrinos, actually they have very small masses. So even though leptons, yes, do interact via gravitation, because neutrinos have such small masses, they have very weak gravitational interactions because their masses are so tiny, any of the forces they experience, this gravitational force, is going to be tiny. So the gravitational force between two subatomic particles is very, very small anyway, but because neutrinos basically have almost zero rest mass, they basically don't experience any sort of gravitational forces kind of ever. They do, but in such a small amount, and certainly between these two, this neutrino and this antineutrino, they're not going to feel any gravitational force kind of whatsoever. Even what I've drawn there is laughably too big compared to what it would be in reality. But even things like a neutrino and the Earth, the neutrino is barely affected by the Earth's gravitational pull at all. They've got such small rest masses that they basically don't experience gravitation in any way comparable to the way we're used to it. So that's one force they practically don't experience. They do, but it's so small. But another one is that they are uncharged. So even though leptons can experience the electromagnetic force if they're charged, these neutrinos don't, because they're uncharged, therefore they don't experience the electromagnetic force. Just as hadrons can experience the electromagnetic force if they're charged, and neutrons don't because they're uncharged, neutrinos don't experience the electromagnetic force either. So this electron is, this is what I've drawn here, this electron, this experiences... Sorry, I'm just making clear that's an electron. They experience a gravitational force still, even though it's... I shouldn't really draw that on there, that it's basically non-existent. There's basically no way I can represent that it actually fits how small the force is. But that is the only force that these two are experiencing here, because they're not experiencing... They're basically not experiencing electromagnetic force because this one is charged, but this one isn't. Neutrinos are never charged, therefore they're not going to experience any electrostatic repulsion here. So the only thing they're feeling is gravity, and they're basically not feeling that as well. So they basically don't interact with matter much at all. And finally, as I was saying, they're leptons. And so because they're leptons, they basically don't experience the strong force either. So leptons, no electron experiences the strong force, so I could replace this with an electron, and there's not going to be anything going on between this electron and this proton in terms of the strong force, but they would be experiencing electromagnetic repulsion, attraction, because this is negative and this is positive. So there would be a different force between the electron and the proton here. But this neutrino basically doesn't experience the strong force at all because it's a lepton, has no charge to it, so it doesn't experience any electrostatic repulsion. There's no electromagnetic forces going on, and this gravitational force is so small, we might as well ignore it. So there's no point really thinking about that either.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.